Okay, so we're looking at problem 1.04 here. Oh, let's get my pen working. I need a new battery for it here. 1.04. And this asks for it's dealing with the age of the universe, which is 14 billion years. And so part A says, write this as, let me make sure I'm reading this right. Write this as two significant figures in power of 10. So the first thing to notice is this is a two significant figure value, because there are only two significant figures here. But we need to do it in power of 10 notation. Now on the little chart you had of powers of 10, we should note that 14, or billion, is the same as 10 to the 9th. Now right over here, 10 to the 3rd is where your thousands come in. 10 to the 6th is where your millions come in. Ten to the 9th is where your billions come in. So it's every 3 sets of zeros we name something, and those are the multiples of 3 that come up. So I can actually replace the word billion with times 10 to the 9th years. But this doesn't match scientific notation fully. Scientific notation says this number has to be between 1 and 10. So we need to move the decimal place over to the left. This means we've made it bigger, and that one movement to the left comes here. And so we write it as 1.4 times 10 to the 10th years. And that's a way of converting this large number into scientific notation. And so we have our significant figures up front. The 1.4, we see 2. And then the 10 times 10 to the 10th tells us the scale of how large that number happens to be in things. Now for part B, we're going to do a conversion here. So I want to change some colors for part B, just because I can. Part B asks us to take this 1.4 times 10 to the 10th years and convert it to seconds. Now, there's two ways to go for this, and I'm going to go the full way first, and then you can look at the other way. And we did this with the activity in class, but I'll show it again. So I know, looking at the sheet in the front of the book, or the handout I gave you for exams, that if I go to my unit conversion, you can be crinkling in the background as I want to quote what they have here, that I can say 1 year is 3.156 times 10 to the 7th seconds. So that's 1 year. So I put the seconds on top because that's what I want. And that's equal to 1 year, so that goes in the bottom. So where did this come from, Jeff? Why did you make this ratio? What I did was, what the textbook is saying is 1 year equals 3.156 times 10 to the 7th seconds. If I divide both sides by 1 year, this front part becomes 1, because anything divided by itself becomes 1, and the second part becomes our conversion ratio. It becomes a factor that we can multiply by things to convert. Now what's nice is if I multiply anything by 1, I get it back again. I get the same thing back. But because this is in the form where my seconds are on top and my years are on the bottom, Well, I told you units act like algebraic, so those will cancel. And I have a multiplication across the top of my fractions. And this is where scientific notation comes way in handy, because what I can do, I'll bring my calculator here, so I'll enter my scientific notation, 1.4, and on this calculator I use EE to the 10th times 3.156 EE to the 7th, and I get 4.418, so 4.418 times 10 to the 17th seconds. We had a multiplication. So the multiplication gets the smallest number of sig figs. Now our conversion here will usually have extra significant figures. But what we measured determines our sig figs. And we had 2. So this becomes 4.4 times 10 to the 17th seconds, because we only want 2 significant figures. I think the question itself forces us to do it that way, in the way they asked, that they said, please use 2 significant figures. But because our measure was given in 2 significant figures, our answer should only be in 2 significant figures. Conversion factors have as many significant figures as we need, unless we can't measure it that accurately. But for most cases, and 100% of what you'll do in this class, whatever we measure, that's usually determining our significant figures. So in this case, it was the 14 billion that only had 2 sig figs. Our answer only has 2 sig figs. There is another way to do this, the way you will see me do occasionally, more often than not. 4 times 10 to the 10th years. So I string together the conversion factors of the things I know off the top of my head, which is 3.65.242 days per year, 24 hours per day, $60 minutes per hour, and 60 seconds per minute. Now the key about a string like this is you still have the algebraic nature, so years and years divide each other out, days and days divide each other out, hours and hours divide each other out, minutes and minutes divide each other out, and I am left with seconds, which is what I want. If I enter all of this into the calculator, I do get the same answer. Now, I'm not going to go through and re-put it in the calculator. At that point, it's mechanical. But you want to get in the habit of doing both of these types of conversions, because when you get used to that conversion sheet we have, some of the units you have will be directly on that sheet, others won't.